You need to construct a fence around an area of 3,969 square meters to build a garden. What are the dimensions x and y of the rectangular pen that will minimize the amount of material needed? So we need to create a rectangular pen. So let's just do a sketch here. And we know that the area of this pen is a constant 3,969 square meters. So the area is 3,969 square meters. The dimensions x and y, I'll call this x and that y, that's fine. We want to find those values so that we minimize the amount of material needed. Okay, so we want to minimize here the total distance around the pen. So we're minimizing perimeter. And perimeter in this case is 2x plus 2y. And that's equal to, we'll call it P for perimeter. The constraint is that the area has to be equal to 3,969 square meters. And that is calculated by taking the two dimensions, x and y, and multiplying them. So whatever x and y are, whatever we find for them, the product of those two values has to be this number right here. Now, the function that we want to minimize has three variables: perimeter, then x and y. We can't do anything with that until we get it down to just two variables. So that's where the constraint will come in. So I could solve the constraint for x perhaps and say x equals 3,969 over y, and then plug that into the perimeter. So the perimeter now would be entirely of the variable y, and this would be 2 times 3,969 divided by y plus 2 times y. Because all I've done is I've substituted in for the variable x. So let's simplify here, and we'll say 2 times 3,969 is, 7938. So this is 7938 divided by y plus 2y. Okay, now to minimize this, we need to find its derivative and set that derivative equal to 0. So the derivative of this function, since it's actually of the form 7938 y to the negative 1 plus 2y. Okay, now I'll just come over here and do that derivative. So that would be, let's see, bringing the negative 1 down times this constant, that would be negative 7938 y to the negative second power, because I subtract 1 from my exponent, then plus 2y, its derivative is just 2. Now I need to set this equal to 0. So 0 equals negative 7938 y to the negative 2 plus 2, and then solve. So let's see, if I'll just move this term over to make it positive, 7938 y to the negative second, and you know what, well, I'll leave it for now, equals 2, and divide this constant over. So that gives me y to the negative second equals 1 over, and this was the 3969. So we'll just cancel out that 2. What it can do next here, y to the negative second is the same thing as 1 over y squared. So effectively, if I just cross multiply here, so y squared times 1, 3969. So this would be y squared equals 3969. You can think of it as just inverting both sides as well. And when I take the square root here, this number is probably just crazy enough to be a perfect square. Oh, I'm going to put the square root out front. So square root of 3969 is 63. Okay. Now technically this should be the plus or minus of 63, but we're talking about physical dimensions here, so it's pretty safe to just eliminate the negative. And then what that means is we need to find the dimension x. We have y here, that's 63 meters. X would be 3969 divided by 63, which is also 63. So there we have it. So the dimensions that will maximize the area of, or minimize the amount of material necessary to build this garden here is 63 by 63.